Welcome back. You are watching Cyber Live, and today I'm going to be joined with Dr. Ken Urquhart from Zscaler. Ken is a leader in zero trust enterprise cybersecurity. He holds 3 degrees in physics and has previously held executive roles at Sun Microsystems, IBM, and Microsoft. Prior to joining Zscaler, Ken consulted with Fortune 2000 companies on 5G, AI, and cybersecurity. Welcome, Ken.
Thank you, Tilly. It's great to be here.
It's great to see you.
Today, we're going to talk about the risks of using artificial intelligence in cybersecurity. Yes, AI is great to help deal with the chronic shortage of people. And there's some things you really need to watch out for. You could find out your AI is your own worst enemy. Let's have a look. So, current threat environment. We all know this. Record high number of attacks, not a lot of people, increasing sophistication from nation-state actors, and more frequent and more aggressive attacks. This is the world we live in today. Here's a live threat map taken, well, it's not live here, but taken from our live threat dashboard approximately 20 minutes before the start of the keynote, showing you the number of attacks that have happened just recently. And you can see a lot of concentration in the United Kingdom and major capitals across Europe. This is constant, day in, day out, 24/7. So what are you going to do? Well, Pillsbury Law and the Economist Intelligence Unit last year commissioned a report, and they asked, what are you going to do? Balancing innovation, execution, and risk. More than half of the executives responding think the best tool to counter nation-state cyber attacks is AI. And because of that, they're looking at the market value of what? Almost 50 billion US dollars by 2027. Huge market. So the answer is, of course, we're going to deploy more AI. Now, in theory, it enables cybersecurity teams to handle more attacks, more complex threats without needing additional people. Remember, massive skill shortage, and we'll get to that in a little bit. Okay, now why AI? Well, it gives your computer the ability to analyze arbitrarily large amounts of data at scale. And it'll fit the patterns, find out what's going on, and help you make better decisions about things you've not seen before. And of course, things that you've seen very common, and it'll help you not make mistakes in classification. Now, there's 3 kinds of AI, and yes, it's going to be a little dull here, but I like to go over them. There's called supervised and unsupervised learning. Now, unsupervised means just throw the data at it, and it'll start making predictions for you. But more importantly, the things that give you the real value are supervised learning, where I say to it, okay, here's some real data, and we know what the outcomes are. You know, pictures in image classification, you say, that's a picture of a horse, that's a picture of a dog, that's a picture of a cat. And you train it. And it gives you guesses based on pictures it hasn't seen before. And you've got regression, the number one approach to AI and machine learning, is that it finds relationships between an arbitrary number of input values and an arbitrary number of output values. And it enables predictions on input values it hasn't seen before. This is probably the most understood, most easily quantified form of machine learning. Classification, this is the big one. This is where you say, I'm going to give you a bunch of data and I know the outcome. And then I'm going to give you data you haven't seen before, and you tell me what you think the outcome is. That's like most often used for things like throwing binaries at it and saying, is this a legitimate document? Is it adware, ransomware, spyware, something else? And hope that it filters through most of them. Finally, clustering. This one, you just put data into it and it says, oh, these look like this, these look like that. And just goes ahead, and the more data you throw at it, the more that the clustering becomes. Now, let's talk about sort of the main applications of AI that you're going to run into. First of all, is trying to limit zero-day attacks. Can an AI shown enough patterns be able to differentiate good from bad? And the thing is, cyber trackers are really efficient in creating new malware, discovering weaknesses in software systems. There's open source software that an attacker can use to generate an arbitrary number of new types of attacks that will defeat local antivirus systems and sneak through. And even without that, There's about 1.5 billion American billions new pieces of malware and unwanted applications created just last year alone. And most of them, 80% of them, especially with ransomware, get installed because a user clicked on a malicious file attachment. So scanning those attachments, trying to find out is it good or bad, is a big business. There's a lot at stake. And the thing about it, AI can go through very quickly, look at any number of previous attacks and try to find those patterns in the document and predict the risk of installing previously unseen software components. Next one, threat prioritization. This is a big deal. Average security analyst, I've heard this number off and on for years, probably gets to look at about 20% of the alerts generated on any given day, and almost half the alerts seen are false positives. It's too easy to miss carefully crafted advanced threats. They're meant to look like a false positive. They're meant to look like something you see all the time. Plus, the other one is we're human. You look at the same thing over and over and over, like log files, your brain starts to say, oh, seen it before. You don't need to worry about it. And so you're starting to miss things. And on top of that, 20% of the serious breaches, remember, we're looking at 20% of the alerts, getting a whole bunch of false positives. Threats are hiding in the false positives. And 20% of the serious breaches often take months to identify and begin remediation. And AI's, the great thing is that it doesn't get tired. It'll work 24/7, just as excited to look at the current analysis as all previous ones, and looking at arbitrary amounts of data. It'll pattern match. It'll pattern match better than the human brain will do. And it'll help you differentiate good from the bad and help you find out which ones you should be putting your time on. Now, another one, automated mitigation. As I said, not a lot of people, 2.7 million cybersecurity professionals short last year alone. And so you get a bunch of alerts where you know what's going to happen. You say, oh, look, ransomware has been detected on the end user devices, started encrypting things, cut it off the network, limit spread. Why do you need a human with a pile of stuff to do, having to also worry about that? It's known risk. You kind of know what it looks like. The risk of mistakes are low. You cut the device off the internet, and it turns out not to be ransomware. One user's inconvenience, but you possibly stopped contagion if it turns out it was real ransomware. Now, AI handles these issues without human intervention, and it can collect and collate a whole bunch of data really quickly and then present it to a human for analytics. Let's get on. Decoys and deception, another fun one. AI is not sentient, but it's good at mimicking what a human does or mimicking what a strategic workload does. And the thing is about advanced cyber attacks, the ones by nation state actors, they're really, really stealthy. 280 days on average to detect. 91% of these incidents don't generate a security alert. Why? They're being done by a human at the other end, carefully watching their steps, doing something that looks normal, avoiding the tripwires, using tools that may be built into the system they're attacking to get around. And the great thing about AI for deception is that you can have fake endpoints, file services, computers, credentials. You can build an entire virtual world to trap a human attacker in. And then once they're in there, you can either alert that, hey, I've got one, or you can play along and the AI can pretend to be a person at the other end that they're trying to deceive, pretend to be a database there. And then you can also feed them false information. You can know what the attacker is made off with. But, and this is the important but, you need to know something about AI ML. It's not infallible. It's not going to become intelligent on you. It's going to do the same thing over and over and over based on what you've told it previously in most cases. And why is that a problem? Well, AI can be fooled. Look at this image. This is the YOLO, you only look once algorithm, meaning you just give it a shot and it just picks out things in the picture. Now, it's got gentleman on the left. Hey, that's a person. Sometimes sees chairs. What about the man on the right? Look at him, walking around, pointing. He's wearing a little picture around his waist, multicolored, looks like people. What's going on? Well, that's fooling the AI. The AI is looking at that image of that man and saying, oh, when I take into account everything, mostly it's not a person, and misidentifies. so much for I can tell who's walking down the hall, I can tell who's coming into the building. They're carrying that like on a knapsack or just holding it in front of them in a bag. You're not going to see them. And these are called data poisoning attacks, meaning you're fooling the AI with modified data to trick it into making an unexpected decision. Check this out. Oh, look, you can transfer the unperson picture. And these are known as adversarial attacks. And in this one particularly, you set one deep neural network against another, and it automatically figures out the best images to use to defeat the first one. And this is a big field of research. It's not like this happens once in a while. This can happen repeatably. And it could be happening to you and your AI right now. Now, let's just think about this. And I'm going to use pictures rather than cybersecurity data because pictures are much easier to understand and perceive. Everything I'm showing you has been duplicated with cybersecurity data from the IT center to show you can achieve the same results of fooling your AI. What's this grainy picture? Looks like random noise, doesn't it? You've got a little blobby thing over on the right. Well, if I put it in front of an AI that does image recognition, it comes back and says it's an armadillo with 99.97% confidence. How come? Well, AIs look at this picture like it's a string of bits with different numbers attached. It's not looking at the picture as a whole. And then it looks for patterns among the colors and the bits. And it turns out you can mess with them just a little bit, as they're called perturbations or modifications. So to you, it still looks like, a nice little gray picture. But to the AI, it says, whoa, that looks like pictures I've seen of armadillos, and I'm pretty confident of it. What about this? Bunch of, again, seeming looks like random noise in little squares. Well, you feed it through the right AI and it comes back, oh, they're the digits 0 to 9. What about this? That looks interesting. Yeah, you've guessed it. It's also the same digit 0 to 9. And this is the kind of things, AI is not infallible. And you ask yourself, well, is it thinking like a person? Why is it doing that? Well, truth is, it's not thinking like a person. It's thinking like an AI. It's a statistical construct making predictions based on what it's seen before. Now, what's going on? Here's some more. Look at this. I've put a decal on a car, and I can tell it it's a cake. Imagine being able to evade an entire city security system, to mess up an entire smart city camera system by putting a decal on your car. There have been tests where you can take an autonomous vehicle and put a picture on the car beside it and cause it to veer sideways unexpectedly. How about on the right? This is another famous one. It took a picture of a stop sign and modified it, in this case by putting some stickers on it, and convinced the AI in the car that it's a speed limit of 45 miles per hour, or a yield sign, or a right turn sign. And you say, wow, so what's going on? And what's going on in data poisoning attacks is AI is really good at taking a bunch of stuff you give it and you say, here's a bunch of pictures of stop signs. Here's a bunch of pictures of speed limit signs. And I want you to tell the difference. And what it does is it does mathematical transformations on those pixels you feed into it. And it separates them in an arbitrarily higher dimensional space. And I know this is probably going to sound, not going to sound like a lot of understanding here, but that's okay. AI people understand this. But what you're essentially doing is you're separating them. As you can see here, all the speed limit signs, the little red triangles, are sitting on one side of this decision boundary drawn by the AI. Stop signs are all on the lower left. And when you put data in that it's not seen before, it uses this to say, does the data fall on one side of the line or the other? And how far away is it from it? And from that, I'm going to give you a prediction of what it is. So what you start to do is use another AI to start messing with the photos of the stop sign. Arbitrarily pictures, arbitrary squares. And because that decision boundary is so complex, and it's something we call overfitting, meaning that we haven't really, we've done so much optimization on the training data we've given it that it has these arbitrarily complex separation. And in those little areas where they come really close to the other data set, you can take like a stop sign, which should be a little blue circle, and you can modify it and it starts to creep up to that decision line and then creeps right across into the speed limit 45-mile-an-hour sign. And you can get them doing that, just crossing the boundary and then the AI will misclassify it. And so how do you solve this? Well, there's techniques in AI where you say, okay, look, I don't want it arbitrarily complex. I want you to make a good decision, but I don't want you to make it so accurate on the training data I've shown you that when I show you instances you haven't seen before, that you'll not make a mistake, that you'll not misclassify like this. And one technique you're going to hear if you've done AI is called regularization. And as a result, you draw a decision boundary that's much more suited to data you haven't seen before, to the larger set of data. And in this case, when you've got this refined decision boundary, your AI looks at those stop signs that have been modified and says, nah, it's still a stop sign. And this is one of the ways you defeat these data poisoning attacks. And there's a number of them been proposed, a number of them been discovered, and a number of countermeasures to them. Let's look at these adversarial attacks. And there's like here, just 7 of them. And at the bottom, you can see the references, and I'll tell you later how to get the slide deck from me so you can see these for yourself. They're all involved in taking data that looks like something and then gently modifying it so that it looks like something else. And there's the limited memory, Broyden, Fletcher, Goldfraud, Shano method, and that's all about finding out how to make minimal image modifications so a human it looks perfectly normal, but to an AI it does something different. It's very compute intensive. So there's also this next one, fast gradient sign method, which does the same thing by modifying every single input variable, possibly every single pixel, every single log entry that comes into it, and then produces false results. And then you've got this next one, the JSMA attack. This one modifies as few variables as possible to do the fake. The deep fool generates arbitrary adversarial results, but you can't make it specific. So if you give it an image of an armadillo, it'll turn it into an image of a horse, but you can't tell in advance that I want to turn that image into the horse. And then we have the 3 other ones to look at. Now, mitigation strategies. Turns out, remember I said, don't overfit on your training data. Don't rely on the training data exclusively. Ways to make it more smoother between the decisions and not have those little nooks and crannies where you can push attack data into. And a really good one, so can machine learning be secure? Is one of the original ones. Great one to get started, very easy to read, goes back about 8 years. And explaining and harvesting adversarial examples gives you some examples on how you can fool deep neural networks. A great review paper, Wild Patterns, 10 years after the rise of adversarial machine learning, kind of goes on, says the state of the art from 2006 to 2017. And finally, newer one, adversarial attacks and defenses. Now, these are paper for AI. I'm not going to say experts, but you need to be able to read a research paper. You need to be able to go through the math. You need to be able to translate that into code. A lot of that's not done for you. Whereas back here on adversarial attacks, for example, the fast gradient sign method, you can get Python code and examples off of a Google's Colab site. And again, that's mentioned down there in the reference. So AI can be great to help you with cybersecurity. Great to make up for the lack of skill and lack of people. Great for dealing with that barrage of known attacks. But you also need to be careful when you're trying to harness it to do things like look for, nation-state adversarial attacks. When you know to make sure you have a lot of good data to train it with, and you need to be careful how you train it, not to over-index on the training data, make it more generalizable to handle data it hasn't seen before. And that's my talk. Questions? Also, you want the paper, you'd like a PDF of it with all the links, scan the QR code, connect with me on LinkedIn. Happy to help you.
Brilliant. Thank you for that presentation, Ken. That was really interesting. So before we end the session, we're going to take a couple of questions from the audience, if that's okay.
Certainly.
So, how can people get started with learning AI and machine learning?
Mm-hmm. Yeah, how does any of what I've just told you make sense? Truth is, you're going to have to be good at math, not just programming. You're going to have to take some courses. Now, the great thing is there's a lot of free courses. On my LinkedIn, which is on the previous slide. Just, you can wind back the video and have a look at it if you're following along virtually. I have an article, How to Get Started in Machine Learning. There is a gentleman named Andrew Ng out of Stanford who does an excellent course on it. And it's kind of the gold standard. If you do that course and it's self-paced, free, you'll come away with a basic understanding of all the math involved, the main algorithms, and you'll be able to actually use them and solve problems. Great news, all those algorithms are encoded in Python, which is sort of the de facto data science language, and you can use it without having to write your own. So, as I said, there's Andrew Ng's Introduction to Machine Learning. There's others. You can certainly find them online. There's a lot of free information out there. There's no reason that you cannot become good at AI and machine learning. Anyone. You just have to want to do it and practice.
Good. That's good advice. So where can people get like example code and more information on the kind of attacks you were speaking about?
Yeah. And again, there's those papers. Reading a paper, which is an academic publication meant to communicate to other people knowledgeable in the area. And I had one academic tell me, Ken, I write these papers. It contains what I think very good stuff, but I think maybe only 12 people in the world read it. Reading papers are a challenge. There's only so much room to publish. There's an assumption you can understand the steps between each part that is presenting. Reducing it to code, especially when they haven't shared the code. And I think people who publish papers in AI, share your code. Come on, it's not going to cost you anything. Don't keep it a secret. Don't make me work for it. And, you can also contact authors of papers and say, hey, can I get the code? And more often than not, they're just going to give it to you. And you can ask some questions. But it is the papers. They are hard. Sometimes when it's cutting edge, especially with newer attacks, you're going to wait a while for someone else to write the code for you. It's a skill.
Okay, great. And a final question, which I think a lot of people probably wonder about. So how can people begin to ask the right questions of vendors who are selling them solutions?
Yeah, I know. And that's an excellent question. I'm sure a lot of what I've said, if you're a business person trying to make purchasing decisions, you're going to say, well, how do I know they've done that? And the answer is you should ask them to explain it to you. I know I've done a really skimming job on this, but if someone really knows what they're doing, they can sit you down, draw a decision boundary, talk to you about the various methods, explain it in a way you can understand. I mean, I've been doing this for years. Yes, you can. Yes, I can sit down with a CEO and make them feel comfortable with what it can and cannot do. But the important thing to know is AI is great. It's a mimic of human behavior. It is not thinking like a human. It's meant to think like a human, to kind of be a human. But it doesn't get tired. It'll review any amount of huge amounts of data for you, and it'll churn out results that you can rely on in well-known situations to make up for the lack of people. But again, if you come away with a salesperson and you don't understand what they've just spoken to you about, ask them to explain it again. Ask them to get one of their experts to explain it to you. Someone who knows what they're doing can make it clear in an hour-long meeting, and you can come away with confidence. So go for it. Ask your questions. Don't let them get away with just blowing it over. Don't sit there and say, I don't want to say anything because I don't want to give the impression I don't know what's going on. If you don't know, ask. There are no dumb questions if you don't understand.
Brilliant. Well, thank you, Ken. We're going to leave it there as we're running out of some time today. So thank you again for joining us.
Thank you. Great. I hope everyone enjoy the rest of the conference.
And thank you all for joining us as well today on Cyber Live, and keep tuned to find out more.